Another planet may be hiding in our solar system, not a theory from science fiction, not a distant exoplanet orbiting another star. A real world made of ice and rock, drifting silently far beyond Neptune and Pluto, so distant that even our most powerful telescopes have never seen it directly. For over a century, scientists have chased its shadow, following strange gravitational clues that suggest something massive is out there, something unseen, something influencing the orbits of distant worlds. And if it exists, it means we may not understand our own solar system as well as we think. The idea that another planet could be hiding in our solar system isn't new. In fact, scientists have been chasing this possibility for more than 100 years. Long before powerful computers or space telescopes existed, astronomers began noticing that something wasn't quite right with the motions of the outer planets. The story begins in the late 18th century with the discovery of Uranus. When astronomers carefully tracked its orbit, they noticed subtle irregularities. At certain points, Uranus appeared to speed up or slow down, as if something unseen were tugging on it. These disturbances, known as gravitational perturbations, suggested the presence of another massive object exerting influence from afar. Using mathematics alone, astronomers calculated where that invisible object should be. In 1846, when telescopes were pointed at the predicted location, Neptune was discovered almost exactly where the equations said it would be. This moment changed astronomy forever. It proved that planets could be found not by seeing them directly, but by detecting their gravitational fingerprints. Encouraged by this success, scientists searched for more disturbances. Later observations suggested a similar wobble in Neptune's orbit, sparking the hunt for yet another planet. That search led to the discovery of Pluto in 1930, but Pluto turned out to be far too small to explain the supposed anomalies. The wobble itself was eventually traced back to measurement errors, not an unseen planet. Still, the idea refused to die. Astronomers had learned a powerful lesson. Just because something can't be seen doesn't mean it isn't there. Gravity leaves clues, and those clues would soon resurface, this time far beyond Pluto, in the darkest reaches of the solar system. For decades, Pluto was thought to be the final frontier, but beyond its orbit lies a vast shadowy region known as the Kuiper Belt, a distant reservoir of ice and rock left over from the formation of the solar system. As telescopes improved in the late 20th and early 21st centuries, astronomers began discovering that this region was far more crowded than anyone expected. Thousands of Pluto-sized objects may be hiding there, along with billions of smaller bodies. Most follow relatively orderly paths around the Sun, but a small group stood out. These distant objects behaved strangely. Their orbits weren't randomly scattered, as physics would predict. Instead, they appeared clustered together, tilted at similar angles, stretched into elongated paths, and aligned in a way that made no sense if gravity from the known planets was the only influence at work. Some of these objects even moved in extreme ways. A few orbited far above and below the plane of the solar system. Others traveled in the opposite direction of the major planets. The deeper astronomers looked, the harder it became to dismiss these patterns as coincidence. This was a familiar situation. Just like Uranus in the 1800s, something unseen appeared to be pulling the strings. But this time, the suspected culprit wasn't another nearby planet. It was something far larger, far heavier, and unimaginably distant. To test this idea, astronomers turned to computer simulations. They recreated the early solar system in a chaotic state and ran it forward under different conditions. In one scenario, the known planets were the only massive bodies present. In another, an additional large planet was added far beyond Neptune. The results were striking. Without an extra planet, the strange Kuiper belt orbits never formed. But when a massive, distant planet was included, the simulations produced the same bizarre alignments seen in real observations. According to these models, the odds of this pattern forming by chance were incredibly small. Something was shaping the outer solar system, and whatever it was hiding far beyond the reach of direct observation. To move beyond coincidence, astronomers needed more than strange patterns. They needed proof grounded in physics. That proof came through detailed computer simulations designed to test whether the outer solar system could behave this way on its own. Researchers began by reconstructing the early solar system in its raw, chaotic state shortly after the planets formed. They allowed gravity to shape the system over billions of years under two different scenarios. In the first, only the known planets were present. In the second, a massive, unseen planet was added far beyond Neptune. The difference was dramatic. Without an additional planet, the Kuiper belt objects scattered randomly, exactly as classical physics predicted. Their orbits failed to align, tilt, or cluster in any meaningful way. But when a large, distant planet was introduced, everything changed. The simulations produced the same unusual orbital patterns seen in real observations, elongated paths, extreme tilts, and synchronized orientations. The match was too precise to ignore. According to these studies, the likelihood that the observed Kuiper belt alignments occurred by chance was less than 1%. Some estimates place the probability as low as 0.4%. In other words, there was overwhelming statistical evidence that something massive was shaping the outer solar system from afar. Based on the models, this hidden world, often referred to as Planet 9, would be at least twice the size of Earth and possibly up to 6 times more massive. Its orbit would be extreme, stretching hundreds of times farther from the Sun than Earth's, and tilted at a noticeable angle compared to the rest of the planets. One full orbit could take as long as 15,000 years. Yet despite its size, this planet would be incredibly difficult to detect. At such distances, even a large object reflects very little sunlight. It would move slowly against the background stars, making it nearly invisible to all but the most powerful telescopes, and even then, only with extraordinary luck. Still, not everyone was convinced. Some scientists warned about observational bias. If you search the sky expecting to find evidence of a hidden planet, are you more likely to interpret unusual data that way? Others proposed alternative explanations, suggesting that our understanding of gravity at extreme distances might be incomplete. But even with skepticism, the evidence refused to disappear. The outer solar system was behaving as if something massive was there, whether astronomers could see it or not. And that raised a far more unsettling possibility. The solar system might still be hiding one of its largest members in plain darkness. Even if the evidence points to a massive hidden planet, one question remains deeply unsettling. How did a world like this end up so far from the Sun? The region where Planet 9 is predicted to orbit is incredibly sparse. There simply wasn't enough material there for a planet of that size to form naturally. This has led scientists to consider 2 leading possibilities. The first is that Planet 9 formed much closer to the Sun, somewhere between Saturn and Neptune, during the chaotic early days of the solar system. As the giant planets migrated and gravitational interactions intensified, this young world may have been violently flung outward, not hard enough to escape the Sun entirely, but far enough to become stranded on the distant edge of its gravitational influence. The second possibility is even more dramatic. Planet 9 may be a rogue planet, a world born around another star and later ejected into interstellar space. Billions of these orphan planets are thought to drift through the galaxy. Long ago, the Sun's gravity may have captured one of them, pulling it into a slow, elongated orbit that still persists today. Either scenario paints Planet 9 as a survivor of cosmic violence. Based on current models, this hidden planet would be an incredibly dense body, composed primarily of rock, metal, and frozen material. It would resemble the exposed core of a planet that never had the chance to fully become a gas giant. Colder, darker, and more lifeless than even Pluto, it would be one of the most extreme environments in the solar system. But some scientists argue that Planet 9 may not exist at all. They point to observational bias, the idea that if researchers are specifically searching for evidence of a hidden planet, they may be more likely to interpret unusual data in that light. Others suggest that gravity itself may behave differently at such enormous distances from the Sun, subtly altering orbital dynamics in ways we don't yet fully understand. There is even a more exotic hypothesis. Some have proposed that the strange gravitational effects could be caused not by a planet, but by a primordial black hole, a tiny but incredibly dense object formed shortly after the Big Bang. Such an object would be almost impossible to detect directly, yet capable of influencing distant orbits. While this idea remains highly speculative, it highlights just how strange the mystery has become. Whether Planet 9 is real, misidentified, or something far stranger, one thing is clear: the outer solar system is far more complex than we once believed, and the final answer may be closer than ever. For now, Planet 9 remains invisible, not because it isn't there, but because it hides in one of the most remote regions of our solar system. At distances hundreds of times farther from the Sun than Earth, even a massive world would appear as a faint, slowly moving dot, nearly indistinguishable from the background stars. But that is about to change. A new generation of telescopes is preparing to scan the sky with a level of precision humanity has never achieved before. Among them is the Vera Rubin Observatory, designed to photograph the entire visible night sky every few days, again and again, for a full decade. Instead of searching for objects one by one, astronomers will create a time-lapse record of the universe itself. In that record, anything that moves will reveal itself. New comets will appear. Interstellar visitors will pass through. Near-Earth asteroids will be tracked in unprecedented detail. And if there truly is another planet hiding in our solar system, its slow, distant motion will eventually give it away. Or, just as importantly, it won't. Because if Planet 9 never appears in these observations, that result will be just as revolutionary. It would force scientists to rethink long-held assumptions about gravity, orbital mechanics, and how planetary systems evolve at their outermost edges. Either way, the outcome will reshape our understanding of the solar system, not by looking outward to distant stars, but by finally uncovering what has been hiding in our own cosmic backyard. We once believed our solar system was finished, complete, fully mapped. Now we know better, and the next discovery may prove that the most surprising planet of all has been here all along, waiting to be found. If you want to stay ahead of discoveries that could rewrite our understanding of space, subscribe for more stories uncovering the hidden side of the universe.